Another type of question you will get is to calculate the pH of a solution given the OH concentration. So there's a couple of steps involved in this. The first step you need to do is calculate the hydronium concentration. And remember, we do that using Kw, or the ionization constant of water, which will always equal 10 to the negative 14, the concentrations when these are multiplied together. So we can solve now for the concentration of hydronium by putting in this in the hydroxide concentration, and we can work out the hydronium concentration is 10 to the negative 11. Step 2, we now use this concentration to work out the pH. You must always use the concentration of hydronium, not of hydroxide. So we'll pop that in and we get a pH of 11. So again, a couple of questions for you to have a go at. When you've given the OH, or the hydroxide concentration, you need to find the pH of these two solutions. Pause it and I'll pop the answers up. Okay, so this one the pH is 3, and for B the pH is 0. Remember, you can have a pH of 0, you can even have a pH of a negative number, but we'll get into that at another time. So if you've had problems with this, remember the work solutions are at the end of the video. Last type of calculation is that you'll be asked to work out the pH of a solution of a hydroxide solution or of a base. So what you need to do again is think of how many hydroxide ions here are forming when the base dissociates in water. So here you'll see sodium hydroxide dissociates into just the hydroxide. So therefore the hydroxide concentration will be equal to the concentration of the sodium hydroxide. So we just need to use this. Step 2, we need to calculate the hydronium concentration. So we put it into this formula here and we solve for the hydronium concentration. Once we've solved for the hydronium concentration, we can calculate the pH. pH equals negative log 10 hydronium concentration, which equals negative log 10 to the negative 11, so pH equals 11. Be careful though when hydroxide dissociates into two hydroxides. You'll see here with magnesium hydroxide, each magnesium hydroxide will make two hydroxide ions. So the hydroxide concentration will equal 2 times the concentration of the magnesium hydroxide. So this is the concentration we need to use of hydroxide ions. So again, step 1, just calculate your hydronium concentration using this formula. Step 2, once we've worked that out, we use this concentration here, which is the hydronium concentration. We pop that into step 2 and we can calculate the pH. So pH equals negative log hydronium concentration. Pop that into your calculator and you'll get a pH of 11.3. So here's the last 2 questions I want you to have a go at. Again, pause the video and I'll pop the answers up. So the answer to A is a pH of 12 and the answer to B is a pH of 12.30. So if you've gotten all of those right, you don't need to watch anymore. I'm going to go through the work solutions on those couple of questions. Question 11. State the pH of the following solution. So here we've got the hydroxide concentration, which equals 10 to the negative 11. The first thing we always need to do is calculate the hydronium concentration, and we do that using this formula. So we plug the concentration that we know in here, and you can solve then for the hydronium concentration and you'll get 10 to the negative 3 molar. Then you can calculate the pH because you've got the hydronium concentration. So pH will be equal to negative log 10 to the negative 3, so pH equals 3. 10b, again we're just working through the same steps. So we know the hydroxide concentration, we need to work out the hydronium concentration. So pop it into this formula here. It's 10 to the negative 14. So we've got hydronium equals 10 to the negative 14 divided by 10 to the negative 14, which equals 1. When you calculate the pH here, negative log of 1 equals 0. That is okay to get a pH of 0. Question 12. Calculate the pH of the following solution. So we've got a 0.01 molar sodium hydroxide solution. So sodium hydroxide will produce its NaOH. So the hydroxide concentration will be equal to the sodium hydroxide concentration. So we just need to calculate the hydronium again using this formula, and we'll get 10 to the negative 14 divided by 0.01, which equals 10 to the negative 12 molar. Calculate your pH and you'll get an answer of 12. And last but not least is a calcium hydroxide. Now remember, for each calcium you're creating 2 hydroxides. So we need to multiply the concentration of calcium hydroxide by 2 to get the concentration of hydroxide ions. So we'll get an answer of 0.02. Pop them into this equation to work out your hydronium concentration, which will be equal to 5 by 10 to the negative 3. Once you've done that, you can calculate your pH. Pop your concentration in here and you'll get a pH of 12.30.